The Genomic Data Infrastructure works on enabling access to genomics data across Europe. It brings together participating countries to build interoperable national nodes and EU-level services that will enable access to high-quality genomics and health data cross-border by 2026. Implementing Federated Analysis Service is crucial because it allows algorithms to travel to the data rather than moving sensitive genomes, preserving privacy and legal compliance while still harnessing Europe-wide statistical power. In this video, we are going to demonstrate federated analysis within GDI project using synthetic genomic data. This demonstrator is a collaborative effort involving 6 GDI nodes: Czech Republic, Portugal, Germany, Slovenia, Estonia, and Spain. The Czech Republic will act as the analysis requester, initiating and dispatching the federated workflows. Meanwhile, all countries will serve as data holding nodes, hosting their own analysis environments where workflows can be executed locally. This setup showcases the non-centralized architecture of federated analysis in GDI, where any node, when properly authenticated and authorized, can initiate an analysis and communicate securely with other nodes. To ensure secure integrated access control across nodes, the entire demonstrator is making use of life science AAI authentication. So we begin by logging into our graphical user interface Sequoia using LSAAI, and we authenticate ourselves through our home organization identity provider. Once logged in, we enter the Sequoia platform ready to configure and launch the analysis. But behind the scenes, our server now holds a valid LSAAI token, which will be later forwarded as part of the federated workflow, enabling secure authenticated communication with other GDI nodes. We prepared a dedicated project to run the federated analysis on individual nodes, as well as a separate project to handle the aggregation of the results from each country. Now we enter the project designed for launching the federated analysis. We'll create new stage for the demonstrator with selected Genome-Wide Association Study as our requested analysis. Below, we see the parameters for the analysis and all 240 synthetic samples distributed across the 6 partner nodes, each tagged with its associated phenotype. We will now select all the samples and start federated analysis. We can see that its status has changed to running, indicating that the federated analysis has been successfully initiated. Next, we switch to the backend view of the GDI Orchestrator API to take a closer look at how the orchestration process works behind the scenes. When the analysis is initiated from the web-based interface, the system sends a JSON task request, including the user's LSAAI authentication token, to the GDI Orchestrator API. The orchestrator then decomposes this request into individual tasks, one for each participating country. It uses the GA4GH Task Execution Service API with the SnakeMake test client to forward these tasks to respective nodes. Importantly, this architecture is not limited to SnakeMake. Other test-compatible workflow engines, such as Nextflow or Galaxy, can also be implemented. We now switch to the Spanish node, where we can see the graphical user interface connected to the local funnel server. Here, the most recent requests correspond to the demonstrator task we just launched. As you can see, each task includes not only the workflow definition, but also a detailed list of input data references. The task on the Spanish node has already been successfully completed, and so we can look inside the Minio file browser, which provides access to the local S3 object storage. In the output bucket, we find the results of the GWAS analysis, the table of associated variants, and a Manhattan plot that visualizes these associations. These results reflect only the Spanish cohort and we are showing them here to highlight the value of federated analysis, where each node can compute results locally while still contributing to pan-European meta-analysis. We manually collected the resulting tables of associated variants from all 6 participating nodes and copied them to the Czech node's object storage, simulating what an outgress mechanism would automate. With this manual step done, we can go back in the Sequoia interface. We open the GDI Aggregation project, where we've already prepared and uploaded all 6 resulting tables. We create a new stage for aggregation, and with everything in place, we launch the aggregation analysis. Once the computation finishes, we'll be able to view the final aggregated report. In the final report, we can see a new Manhattan plot, again showing the statistical significance of variant associations with the phenotypes. But this time, these associations are aggregated over all 6 participating countries. Below the plot, we have a detailed table listing the 20 most statistically significant variants, including a breakdown of their individual significance scores for each country. This can be used as a demonstration of the real value of federated analysis, which allows researchers and clinicians to gain deeper insights by comparing signals across national cohorts, understanding where results align, where they diverge, and what patterns emerge at the pan-European level. It's a powerful example of how secure distributed analysis can support both local relevance and broader scientific discovery. At the end of this video, we'd like to extend our sincere thanks to all participating nodes and all dedicated colleagues who worked hard to make this demonstrator a reality.